Let's look at the question. How many moles of carbon monoxide are there in 8.0 liters of 0.060 molar carbon monoxide solution? First thing I'm going to do is make a list of the information I was given. I have 8.0 liters of the solution. That is 0.060 molar in concentration. The first thing I need to do is figure out which one of these amounts I want to start my calculation with. One thing that will help is if I rewrite molarity in the correct fashion. So I'm going to rewrite this molarity as it should appear, which is 0.060 moles of carbon monoxide per 1 liter of solution. By doing this, I realized that the 8.0 has only one unit associated with it, whereas the molarity actually has 2 units associated with it. When determining where I'm going to start my calculations, I'll always start with a value that has only 1 unit associated with it. So I'll be starting with the 8.0 liters. The next thing I need to do is figure out what I want to solve for, and in this case I want to solve for moles of CO. Okay, so now that I know what I'm starting with, I will put that into the mathematical equation. And now I need something to go between volume and quantity. Anytime you need something to go with volume and quantity, where that quantity is moles, you're going to want your molarity. Now, with respect to the molarity that we were given in the question, which was 0.06 molar, keep in mind that whether it is moles over liters or liters over moles in the calculation is directly dependent upon what you need to get rid of. In this particular case, I need to get rid of the 8.0 liters of solution. So out of the molarity that I have, I am going to put the liters of solution into the denominator with the molarity in the numerator, or the moles in the numerator. And now I'm ready to solve this. So we have 8.0 times 0.06, which gives us 0.48 liters, moles of CO. The next thing we need to do is make sure we have the correct number of significant digits. This is multiplication and division, so the result should have the same number of digits as the measurement with the fewest. 8.0 has 2 significant digits because zeros at the end of the number after a decimal are significant. The 0.060 also has 2 significant figures because zeros at the end of the number after a decimal are significant, whereas zeros that precede the first non-zero digit are not significant. So our answer we have 2 significant figures times 2 significant figures divided by an unlimited number of significant figures. 2 was our smallest, and therefore we write the answer to 2 significant digits. So it would be 0.48 moles of carbon monoxide.